Hello, everyone. My name is Shuo, and today's talk summarizes the second phase of the research concerning the regional characterization of porosity and permeability testing data within the deep subsurface of the Silurian Lockport Group. So this project involves the petrographic assessment of selected core test intervals in order to address some of the geological controls on the Lockport Group porosity and the permeability variations. The targeted units include the Salina A-1 Carbonate and the Lockport Group that comprises 4 formations from base to top, including the Gasport, Gold Island, Eramosa, and Guelph formations as marked by the red box. Lockport Group is the most significant potable bedrock groundwater resource in southwestern Ontario, and it is also the most important oil and gas reservoirs and subsurface gas storage units. Recent studies by the OGS reveal a new model that the carbonates in Lockport Group deposited in shallow water on the easterly dipping and tectonically active carbonate ramp, as shown in the figure to the right. So the data includes a total of 150 core wells and more than 11,000 porosity and permeability datasets. Based on the lithophysis analysis, the study area has been subdivided into 3 broad depositional realms. Area 1 represents the inner to middle ramp deposition where the pinnacle structures occur. Area 2 represents the ramp deposits where karstification is rare and pinnacle structure is absent. Area 3 represents the inner to middle ramp setting in the northwest to southeast direction. As marked by the yellow dashed line, the northwest end of Area 3 is dominated by carbonate bank deposits, and in southeast Area 3, local reef mount facies developed near the platform edge. Now let's take a look at the porosity and the permeability data distribution in each area by formation. The data has been grouped by areas, including the inner-pinnacle, pinnacle, northwest, and southeast part of the Area 3. These box bars indicate the most common data distribution of porosity to the left and the maximum horizontal permeability data to the right. The red dots represent the mean value of porosity and permeability. What can be noted is that in the pinnacle structures, the Gasport is relatively less porous and permeable than those in the inter-pinnacle areas. And we do see highly permeable examples where the karstic condates penetrate into the Gasport formation in the inter-pinnacle regions, marked by the outliers. We have limited data in Area 3, so not enough to support any regional trend evaluation. The Gold Island formation is relatively porous in Area 1 and the southeast Area 3 that forms as the lower part of the oil and gas pools. It is similar to the Gasport formation that the permeable intervals occur where the karstification penetrates into the Gold Island. Also in Area 3, it corresponds well with its thickening in gas pools where the reef mount facies developed. Guelph formation is the best studied formation in Lockport Group. And similar to Gold Island, it is porous in pinnacles and gas pools in southeast Area 3. Within the inter-pinnacle regions, Guelph formation is relatively porous with variable permeability outliers marked by the black dots. And in Area 3, the porosity and permeability increase from the bank facies southeasterly into the platform edge, as you can see the change of dot size in both maps. This is in response to the general thickening of the Lockport and occurrence of bioherns. Salina Group A-1 Carbonate is preferably deposited on the lowlands on top of the Guelph formation. It is relatively thin over the pinnacle structures and thicker in the inter-pinnacle regions. It is porous in the pinnacle structures and southeast area 3 that forms the top of the oil and gas pools, but becomes relatively dense in the inter-pinnacle region. So in summary, the porosity and permeability variations of the Lockport Group correlate well with the stratigraphic architecture in pinnacle structure bearing region. Within the pinnacle structures, where the Lockport Group is thickest, the average porosity and permeability values are highest, illustrated by those data percentile distribution charts. Within the interpinnacle region, the karstic penetration enhanced the overall porosity and permeability of the Lockport. In Area 3, the regional porosity and permeability has a general increasing trend southeasterly that corresponds well with the local thickening of strata units and occurrence of reef mount facies in Gasport and Gold Island near the edge of the platform interior. From this slide, we'll display some core and thin section examples that help illustrate the geological controls concerning the formation and destruction of porosity. These 3 wells are examples from the terminus pool in the pinnacle structure in Area 1. Those red boxes indicate the oil and gas reservoir intervals. Guelph Formation possesses the modic porosity, intercrystalline porosity, and the irregular vugs. There are various karstic intervals indicated by those recrystalline features. In the A-1 carbonate, the leaching-enhanced fenestral vugs that are parallel to the bedding planes are well developed that forms the uppermost part of this reservoir. Although dolomitized and clouded in the appearance that have been altered by some depositional features, those microporosity are well observed in thin sections. Dominating porosity types are intercrystalline and intercrystalline porosity in the carbonate matrix and modic porosity after non-skeletal palloys. In the Salina A-1 carbonate, those irregular intercrystalline porosity are well controlled by the horizontal growth of the algal mass below, which may in turn control the lateral flow of the formational fluids. In Guelph Formation, those modic porosity are reduced by the Dolomite cementation and are well connected but poorly directional confined. In Gold Island Formation, the porosity are less well connected, though large vugs may have occurred. Within the interpinnacle karst region, there is a pronounced thinning of all formations in Lockport Group and a great thickening of the A-1 carbonate. Dissolution enhanced the fenestral vugs of the A-1 carbonate are very common, and highly karstic features occur in the Guelph Formation, including the karst rubbles and the recrystallized matrix, which means the whole Guelph Formation has been dissolved or removed, resulting in a thin unit. The Salina A-1 carbonate is dominated by algal laminites and the palloys. Those horizontal intercrystalline porosity is usually controlled by the horizontal algal mats, and the intraparticle porosity may form within the palloys, which all increase the overall porosity of A-1 carbonate. Intercrystalline porosity and irregular vugs that may have formed through dissolution and cementation are most common porosity types in Guelph. And the irregular vugs in Gold Island Formation is common that have been partly plugged by these euhedral dolomite crystals. So in this area, all the formations have been dolomitized except for the A-1 carbonate in the interpinnacle region. The porosity has been controlled by diagenetic processes such as dissolution, karstification, and dolomitization, and reduced by cementation. In the pinnacle structures, the karstic intervals do occur in the Guelph Formation, and the interpinnacle karst region, the karst rubbles dominate the Guelph Formation that enhance the overall porosity. As we move easterly into the northwest area 3, no oil and gas pools occur in the Lockport Group, and these dolstones maintain the lowest average porosity and permeability in southern Ontario. Modic and intercrystalline porosity dolomite are the key rock units in the Lockport Group, and the finestral rocks developed in the algal mudstone of the A-1 carbonate. But the matrix of this dolostone is highly bioturbated and well cemented that reduced the overall porosity. Anhydro and euhydro dolomite crystals have replaced the depositional calcites, giving these dolostones a coarsely crystalline look. Those dolomites are recrystallized and coarsening in this area. Rocks in Guelph Formation are reduced by dolomite cementation, and dolostones show those clotted and pyloidal fabrics in Gold Island and Gasport formations that are also well cemented by euhydro dolomites, which are not well connected. Stylolytes do occur as undissolved argillaceous residues that may have controlled the formational water flow or the dolomite recrystallization during the late diagenetic stages. Tracing southwestward into Area 3 near the edge of the carbonate ramp, the thickening of the Lockport is regionally consistent with some localized thickening recorded in some small areas along Lake Erie where the natural gas pools have formed. The rock units that form the Tilbury gas pool include the lower A-1 Carb, Guelph, and the upper Gold Island formations. The Vox and the modic porosity dominate the Guelph formation. Occurrence of stromatopyrite coral skeletal bound stones in the Gold Island formation that form the localized reef-mounting facies may have accounted for the enhanced porosity as shown in the photo to the right. Those karstic chondrites are pretty evident near the top of the Gold Island formation that marks a key unconformity. So in this area, the dolomites are finer crystalline compared to those in Northwest Area 3. The Vox and the modic porosity are most common in Lockport, and the Gold Island formation displays enhanced porosity by dissolution. So in Area 3, the regional porosity and permeability distribution is controlled by a variety of factors, including the lithofacies, textural variations, and diagenetic history. And in Northwest area, the porosity has been highly reduced by dolomite recrystallization and cementation. And in Southeast Area 3, the occurrence of biohermal facies increased formational thickness and the overall porosity. So the primary porosity has been altered by diagenetic cementation, dissolution, and dolomitization throughout the whole area. And especially within the pinnacle structures, the karstification has played an important role in controlling diagenetic water flow pathways and the enhancement of the overall porosity. What should also be noted is that in the platform facies in Area 3, the oil and gas intervals can extend down into the Gold Island formation where the reef-bound facies or bioherm facies occur. So thanks for listening, and I'll be at the discussion panel to answer questions.